also go ahead and bring up this site, CryptoPals. This is a great site to get started with crypto stuff. Basically, it basically walks you through, basic base conversions. Everybody should be familiar enough with this by now that I'm not going to worry about that. But it goes through basically what we just talked about with single byte XOR. Detecting single character XOR, implementing the repeating key XOR stuff that we talked about earlier, and breaking it. So we're going to go through and just talk a little bit and implement single byte and multi-byte XOR stuff really quickly, just to make sure everybody's familiar with it, because again, it's a useful thing to be comfortable with moving between byte representation and character representation in Python, because they're different. So we have a message. Again, it'll be hello. And in this case, we're just going to start with a single byte XOR. And for simplicity, we'll just say that the key itself, we're just going to say it's already a number. We aren't going to worry about making it a string for single byte. For multi-byte, we will. But again, I believe 60 is what I used in the slides. So we'll just go through with this. So in Python, right, characters, you can't XOR characters and numbers, because characters are, even single characters are a length 1 string, and ints are ints, and XOR can't do that automatically. So in Python, I know, or I'm 99% sure we've used this at some point before. You need to use the ORD function, which basically takes a character and returns the representation of it as an integer. So this uses ASCII encoding. If we say ORD of A, and just look at that in hex, you've all probably seen this at least once in binary exploitation. So we can go through and manually ORD like 0 XOR K, and that's the first byte of the output, and now we need to transform that back into a character with CHR, car, and that ends up being a lowercase t. So cool, but how do we make this how do we do this in a loop? And more importantly, how can we easily do all this succinctly? So right, if you wanted to do this one way, you could just have an empty string. So our ciphertext is just going to start off being an empty string, and then we'll just say, like, for each character in our message, if I can type, then we will append to, or actually that won't work. Let's say for ch in message, then we're going to append to C the character representation of the ordinal of the character XOR with our key K, run that, and then there's that. Great. We can do it like this, or Python has the nice ability to, or strings at least, have a join function. So you can do string.join, and then some list or some generator or something that dissolves into a list effectively in here. So if we just hardcode in ABC to see what this does, you can see it just joins all three together. And the reason this empty string is here is because this is the separator, essentially. So if we put a space in there, you can see it returns A space B space C. And so this is really nice to do quick transformations, because we can then in here just put our loop. So we can say we want to join character of the ordinal of each character in our string for each character in our message, and I keep forgetting that, I cannot type, and we get the same result back, and it's a little bit cleaner to do it in one line, right? Everybody can still read what's going on, and one thing that's nice to do with XOR stuff is just build up a small library of these functions, right? It takes 2 seconds to write these, and so we can just say define this as like single byte XOR given a message and a key. And you now always have that function, and you can import it from whatever scripts you want, or just copy and paste it in. It's a really nice thing to have. What I would say is probably more useful, though, is doing a multi-byte XOR. So basically XORing 2 strings together. And for those who don't know, so well, actually let's set a key really quickly. If our input is message hello, we'll use foobar again. Python has some built-in functions that are really nice for this kind of stuff, one of which is the zip function, which basically you give it two things. So in this case, we're going to give it m, our message, and k, our key, which is now foobar. And it will return a list of tuples where basically the first item of m and the first item of k are put together in one of the tuples. And then the next one will be the second letter of m and the second letter of k. And so this is really nice for this kind of stuff because we can now succinctly do the same thing where we can join the character representation of, let me add a little bit of space here. We can take the character representation of the ordinal of like our message character and our key character for each message character and each key character in this zipped result, and we get our multi-byte XOR just in one line. This one line right here is probably one of the most useful things that we'll talk about today, just having that quick, easy way to do a multi-byte XOR. And again, we can demo some of the properties of XOR. So we'll call this string XOR given a message and a key. Just define that like that. And so, we can string, yes, thank you. So we can string XOR, our actual message and our key, and we get that. And again, though, XOR is its own inverse. So if we XOR the result of that with the key again, we get our message back out. And consequently, if we XOR this with our message, we get our key back out. Does everybody realize why that works? And does it all make sense so far? Okay, cool. In Python 2, a lot of the times encoded blobs will be given as base 64, and you can just do base 64 data dot decode hex, or dot decode base 64. What am I doing? And it'll give you the result that you should actually be working with. One thing that you have to get very clear about when you're working with crypto stuff is making sure that you aren't trying to XOR base 64 data. You need to decode it back into raw bytes and then work with it from there. You should essentially always be keeping your data in raw byte form as soon as you get it in, just because that eliminates a lot of pain where you're like, why isn't this working? And you realize you're trying to XOR the key, or you're trying to XOR something with the key where the key is still hex encoded, for instance. Likewise, what I was going to do, if you have some blob of hex encoded data, just again .decode hex, and then that'll give you that. And you should always be saving and working with these decoded blobs. You can also .encode to transform back into base 64 hex if that's what the solution is looking for, but always be working with this. Let's see. So yeah, this is a useful thing just to have write that yourself, copy it down from the lecture, whatever. Have it. It's a really nice one just to have easily accessible to copy and paste from. Let me get out of this. Okay. So any questions about that? Transforming data in Python stuff. Cool. All right. Let me go back into PowerPoint. Actually, stop this.